Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter functions. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And in any other chapter, if you have more difficulty, then please mention the name of that chapter also. So here it is told that to find the range of the function f of x, that is equal to 4 sine inverse of x square by x square plus 1. So here so now x square by x square plus 1, this can be written as 1 minus 1 by x square plus 1. Now x square value is always greater than or equal to 0 only. It means that x square plus 1 value will be always greater than or equal to 1. So 1 by x square plus 1, that will go from 0 to 1. So therefore 1 minus 1 by x square plus 1, that will go from okay, this minus of this will go from minus 1 to 0. So this will go from 0 to 1. So therefore x square by x square plus 1 value, that is going from 0 to 1. Now if I apply sine inverse, that will be sine inverse x square by x square plus 1. That will go from 0 to pi by 2. Sine inverse 1 is pi by 2. Sine inverse 0 is 0. Then 4 into sine inverse x square by x square plus 1. That will go from 0 to 2 pi. So therefore the value of the function f of x that belongs to 0 to 2 pi. So option B is the correct answer. Then here it is told g of x for x belongs to R, two real valued function f of x and g of x such that g of x equals to root x plus 1 and f of g of x that is equal to x plus 3 minus root x. And f of 0 is equal to f of g of x that will be equal to x plus 3 minus root x. So this can be written as root x plus 1 whole square. That will be equal to x plus 1 plus 2 root x. X plus 1 plus 2 root x So it means this can be written as x plus 1 plus 2 root x, then minus 3 root x minus 4. It means I can write it as x plus root x plus 1 whole square minus 3 into root x plus 1, then minus 1. So therefore f of g of x, that can be written as this is g of x whole square minus 3 into g of x minus 1. So therefore f of x, that will be equal to x square minus 3x minus 1. So now f of 0, that will be equal to minus 1. This will be minus 3 root x plus I need 2 actually, since y it is plus 3. So this will be plus, this is minus 3 plus 1 minus 3, so minus 2 plus 5. This will be plus 5. So f of x is x square minus 3x plus 5. So therefore f of 0 will be plus 5. So option A is the correct answer. Then here it is told, let D be the domain of the function f of x equals to sine inverse of log 6 plus 2 log x base 3 divided by minus 5x base is 3x. If the range of the function g defined by g of x equals to x minus bracket x, then alpha square plus 5 by beta, that is equal to how much? So alpha square plus 5 by beta value we have to find out. D is the domain of this function and G maps from D to R. So the range of G has been told, that is equal to alpha to beta. Then alpha square plus 5 by beta, that is equal to. Now here, since x is there inside log function, so x should be greater than 0. And 3x should not be equal to 1. X should not be equal to 1 by 3. And also this 6 plus 2 log x base 3 divided by minus 5x, that should be from, that should be also greater than 0. It should be also greater than 0. So therefore 6 plus 2 log x base 3, that should be greater than 0. And 2 log x base 3, that is greater than minus 6. So therefore log x base 3, that is greater than minus 3. Therefore, from here we can say that log x base 3 that is greater than minus 3. So therefore, x should be greater than 3 power minus 3. It means that x should be greater than 1 by 27. And then this log of base 3x, 6 plus 2 log x base 3 divided by minus 5x, that should be from minus 1 to 1. Since the sine inverse y, that is defined only if only if y is from minus 1 to 1. So now this means we can say 6 plus log x base 3 by minus 5x. That will be going from 3x power minus 1 means 1 by 3x to 3x power 1, that is 3x. So therefore I can say 6 plus 2 log x base 3 divided by minus 5x should be greater than or equal to 1 by 3x, greater than or equal to 1 by 3x, and also 6 plus 2 log x base 3 divided by minus 5x, that is less than or equal to 3x. So if we solve this, then we will get that x and x I can cancel. Then I can say this will be 18 plus, since x is not 0, so we can cancel out. So 18 plus 6 log x base 3, that is greater than or equal to minus 5. We are multiplying with minus 5 on both sides, then inequality sign will change. And multiplying with 3 on both sides, inequality sign will not change. Yeah. So this will be 6 log x base 3, that is less than or equal to minus 5 minus 18, that is minus 23. So it means that log x base 3, that is less than or equal to minus 23 by 6. So therefore x should be less than or equal to 3 power minus 23 by 6. And here, mm, so this is like 6 3 is 18. It is slightly less than 4. So it is less than 1 by 27 also. And this will be x plus 6 plus 2 log x base 3, that is greater than or equal to minus 5. This is minus 15x square. So it means that 15x square plus 2 log x base 3 plus 6, that is greater than or equal to 0. So if x is greater than 0, this will be always greater than 0 only. So this means x belongs to R. Okay. It means that x should go from 3 power minus 23 by 3. So it should go from 1 by 27 to 3 power minus 23 by 3. Minus 23 by 6. Actually, x should be more than this. This is more than minus 5. Then x 6 log x base 3, that should be more than or equal to minus 23. Then it means x should be more than or equal to 3 power minus 23 by 6. So it means x should belong to 3 power. So we have to take the intersection of these sets. So x should belong to 3 power minus 23 by 6 till 3 power till 1 by 27. So this is alpha, this is beta. So therefore, we have to find the value of alpha square plus 5 by beta value. Alpha square by plus 5 by beta value, that is equal to 3 power minus 23 by 6 whole power 2 plus 5 by 1 by 27. So this is 27 plus, so this is equal to 27 into 5 plus 3 power minus 23 by 3. So 21. Okay, so this is a very small value, which is less from 0 to 1, a very small value from 0 to 1. And this value will be 3 sevens are 21. No, 5 sevens are 35. 10, 135. So 135 plus 0 point something we'll get. So the range of G. Okay, so this value is equal to nearly 135. It is nearly 135. So option D is the correct answer. Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter functions. So any doubts if you have in any steps, then please write that in the comments. We shall obviously clarify them in the subsequent videos. And also in any other chapter of maths, if you have more difficulty, then please mention the name of that chapter also in the comments. Then we shall give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be on every chapter of maths will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told to find the domain of this function f of x, which is 1 by square root of bracket x whole square minus 3 into bracket x minus 10, where bracket x is called as the greatest integer of, function. It is the greatest integer less than or equal to x. So now, therefore, it is this part should be greater than 0, since why it is inside the square root, and since it is in the denominator also, so its value should be greater than 0 only. So bracket x square minus 3 bracket x minus 10, that should be greater than 0, then I can say that if we factorize it, then we'll get bracket x minus 5 into bracket x plus 2, that should be greater than 0. So it means that bracket x should be either greater than 5 or bracket x should be less than minus 2. So therefore, bracket x should belong to minus infinity to minus 2 union 5 to infinity. So now bracket x is going from 5 to infinity, where 5 is not included. Okay. So it means that bracket x should go from minus infinity to minus 2 union 6 to infinity. Or it means here also I can say that since why bracket x should be always an integer only. Bracket x is always, it belongs to z. So therefore it should go till minus 3. So if bracket x goes till minus 3, then x should belong to minus infinity to minus 2 union 6 to infinity. So x should belong, so therefore this is the domain of this function. Minus infinity to minus 2 union 6 to infinity. So option A is the correct answer. And here it is told f of x, the function f of x, that is given as tan 1 degree into x, plus log base e 123 divided by x log 1234 base e minus tan 1 degree, where x is greater than 0. Then we have to find the least value of f of x plus f of 4 by x. This, its minimum value we have to find out. So now let's say if I take this tan 1 degree as x, no, as a suppose, and log 123 base e, this if I take it as b, since why all these things will be some constants, so we can take them as a, b and c. So log base e 1 2 3 4, that also we can take it as some constant c. So therefore we can write f of x as ax plus b divided by, say, cx minus a. So now therefore f of x, that will be how much? That will be equal to a into f of x plus b divided by c into f of x minus a. So in place of x, we have to put f of x here. So it will be a into ax plus b by cx minus a plus b divided by c into ax plus b divided by cx minus a minus a. So this will be equal to a square x plus ab plus f of x. So that will be equal to a square x plus ab plus this will be b into this bcx minus ab divided by, this is cx minus a, divided by, this will be ca or acx plus bc then minus acx, then plus a square divided by cx minus a. The cx minus a, part will get cancelled, and here also ab will get cancelled. Here acx will get cancelled. So this will come a square x plus bcx divided by a square plus bc. So from here x, if I take it as common, this will be x into a square plus bc divided by a square plus bc. So they will cancel out, then it will be x. So f of x is x. So therefore, similarly, f of 4 by x, that also will be equal to 4 by x. Now, therefore, we have to find the least value of this function. So therefore, x plus 4 by x, we have to find the minimum value of this. So x is greater than 0 only. So therefore, we can write it. This will be root x plus 2 by root x. So this is root x square plus 2 by root x square, I can write. Or we can apply arithmetic mean is greater than geometric mean. We know that arithmetic mean is greater than or equal to geometric mean. So therefore, their arithmetic mean will be x plus 4 by x by 2, and geometric mean, that will be root over x into 4 by x, which is root over 4, that is 2. So therefore, x plus 4 by x by 2, that is greater than or equal to 2. So therefore, x plus 4 by x, that is greater than or equal to 4. So therefore, its minimum value, that is 4. So option B is the correct answer. Then here it is told that let the sets A and B denote the domain and range respectively of the function. So A is the domain of the function f of x, and B is the range of the function f of x, where f of x is given as 1 by root over, this is, so it is the smallest integer function. So it is smallest integral part of x minus x. So this smallest integer part, it is the smallest integer greater than or equal to x. So if x is an integer, if x belongs to z, then the smallest integer greater than or equal to x will be same as the greatest integer function only. And if x does not belong to z, means if x is not an integer, then uh, the smallest integer of x, that is greater than or equal to x, so that will be bracket x plus 1, where bracket x is the greatest integer function, where bracket x is the greatest integer less than or equal to x. Greatest integer less than or equal to x. So therefore, this function, which is 1 by square root of smallest integer of x minus x, so that can be written as 1 by, so when so this will be 1 by square root of bracket x minus x if x belongs to z, and it will be 1 by square root of bracket x plus 1 minus x if x does not belong to z. So now, therefore, as we know that x can be written as greatest integer function of x, the greatest integer of x plus the fractional part of x. So therefore, x bracket x minus x, that is equal to minus of fractional part of x, where so this is where this is the fractional part of x, fractional part of x. So now this fractional part, as we know, it goes from 0 to 1. It can be 0 also, but it is always less than 1. So now this function f of x that can be written as this is be 1 by square root of minus of fractional part of x if x belongs to z. And here as we know that this fractional part of x will be equal to 0 when x belongs to z. So it means 1 by 0 will come here. So it will be undefined. So when x belongs to z, the function f is undefined. And when x does not belong to z, that will be square root 1 by square root of 1 minus fractional part of x if x does not belong to z. So therefore the domain of the function x, of the function f, is r minus z, or r minus z, since we should not put integral value of x, else it will be undefined. And so the range of f that we have to find out, range of f. Now fractional part of x, the function of fx is nothing but 1 by square root of 1 minus fractional part of x, and x does not, so x belongs to r minus z. So now here hmm, so as you know, fractional part of x that will always go from 0 to 1. So therefore 1 minus fractional part of x that will also go from 0 to 1. It can be 1 also. Now 1 by square root of 1 minus the fractional part of x, since it is 0 to 1, so it will be always greater than or equal to 1. It will be always greater than or equal to 1 only. So therefore the range, and here actually it can't be 0, fractional part of x can't be 0 here, since here x belongs to r minus z. So it will go from 0, so 0 is not included here. So here 1 also should not be included. So here also 1 should not be included. So we should not include 0 here. So 1 by, so therefore the function f of x will be always greater than 1. So therefore the range of f is 1 to infinity. So this is the set A, this is the set B. The domain of f is A and range of f is B. So now we have to find A intersection B. A intersection B. So intersection B is nothing but 1 to infinity, 1 to infinity minus the integral values from 1 to infinity, which is nothing but the natural numbers. So 1 to infinity minus n, if you do, that will be the value, that will be the set A intersection B. So S1 is true, only S1 is true, and S2 is false. So option B is the correct answer. Yep. Then here it is told, let f be a function which maps from r minus uh, r minus 0 comma 1 to r, such that f of x, that f of x plus f of 1 by 1 minus x, that is equal to 1 plus x. Then f of 2 we have to find out. So now if I put x equal to 2, suppose, then we will get f of 2 plus f of 1 by 1 minus 2, that is equal to 1 plus 2. So therefore it means f of 2, this is minus 1. So this is plus f of minus 1, that is equal to 3. And similarly, if we put x equal to minus 1, suppose, then we will get f of minus 1 plus f of 1 by 1 plus 1, 1 by 1 minus of minus 1, that is plus 1. So that is equal to 1 plus minus 1, that is equal to 0. So therefore f of minus 1 plus f of half, that is equal to 0. So this is your, let's say our equation 1, this is equation 2. And then suppose if we put x equal to half, then we will get f of half plus f of 1 by 1 minus half, that is equal to 1 plus half. 1 plus half 1 plus half plus half. So it means this is f of half plus f of, this is 1 by half, that is f of 2, that is equal to 3 by 2. So this is equation 3. So now we need f of 2. So therefore, if I do equation 1 plus equation 3 minus equation 2, then we will get, this will be f of half plus f of 2 plus equation 1, that is f of 2 plus f of minus 1 minus of, this is f of minus 1 minus f of half. That will be equal to 3 by 2 plus 3 minus 0. So here f of minus 1 will get cancelled, f of half will get cancelled. So we will get 2 f of 2, that is equal to 2 3 is 6, 9 by 2. So therefore f of 2 will be equal to 9 by 4. F of 2 is 9 by 4. So option A is the correct answer. Then here it is told if the function f of x, that is this 1 plus sine square x cos square x sine 2x sine square x 1 plus cos square x. So f of x, let's say we write it, the f of x is the determinant of 1 plus sine square x cos square x sine 2x sine square x 1 plus cos square x sine 2x. Here we have sine square x cos square x 1 plus sine 2x, where x belongs to pi by 6 to pi by 3. Pi by 6 to pi by 3. If alpha and beta respectively are the maximum and the minimum values of f, then alpha and beta, okay, alpha is the maximum value of f of x and beta is the minimum value of f of x. Then we have to find the relation in between alpha and beta. So now f of x, here if we do column 1 goes to column 1 plus column 2 plus column 3, then we will get, this will be 1 sine square x plus cos square x is 1, so it will be, this will be 2 plus 2 sine 2 plus sine 2x, 2 plus sine 2x. Here it will be cos square x, here it will be sine 2x. Here again this will be sine square x plus cos square x, that is 1. So 1 plus 1 2, 2 plus sine 2x, and this is 1 plus cos square x, this is sine 2x, and then this will be also sine square x plus cos square x is 1, 1 plus 1 2, so 2 plus sine 2x, this will be cos square x, this will be 1 plus sine 2x. So then from the column 1, we can take 2 plus sine 2x as common. And then we'll get into this into the determinant of 1 cos square x sine 2x 1. So in the first column it will be 1 1 1, and here it will be cos square x 1 plus cos square x and cos square x in the second column, and the third column it will be sine 2x and 1 plus sine 2x. Now what we can do, we can do r1, or r2 goes to r2 minus r1, and we can do r3 goes to r3 minus r1. Then what we will get, so therefore this function f of x, that is equal to 2 plus sine 2x 2 plus sine 2x into, this will be the determinant of 1 cos square x sine 2x. Then here this will be 1 minus 1, that is 0 here. This will be 1 plus cos square x minus cos square x, that is 1. Sine 2x minus sine 2x, that is 0. Here also 1 minus 1, this will be 0. And here cos square x minus cos square x, this will be 0. 1 plus sine 2x minus sine 2x, that will be 1. So this will be 2 plus sine 2x into, if we expand this determinant along the first column, then we will get 1 into first row and first column we will exclude. So this will be 1 minus 1 into 1 minus 0. So this will be 1 only. So this will be, so therefore f of x is nothing but 2 plus sine 2x. So now therefore sine 2x value, as we know, it will go from minus 1 to 1. Now, so 2 plus sine 2x, if we add 2 on all sides, then we will get, it will go from 1 to 3. So therefore, the maximum value of f of x, that is alpha, maximum value of f that is alpha, that is equal to 3, and minimum value of the function f, that is equal to beta, that is equal to 1. So beta is 1, alpha is 3. So therefore now we have got alpha is 3, beta is 1. So therefore now alpha square minus beta square, that will be equal to 9 minus 1, that is equal to 8. And alpha square plus beta square, that will be equal to 9 plus 1, that is equal to 10. So option D and option A are not correct. And then beta square plus 2 root alpha, that will be equal to 1 plus 2 root 3. 1 plus 2 root 3. And beta square minus 2 alpha. Sorry. Here actually we sine 2x, here actually this is wrong. Sorry. Here actually the domain is not real numbers. The domain is from pi by 6 to pi by 3. Pi by 6 to pi by 3. The domain is from pi by 6 to pi by 3. This is wrong. So now sine 2x graph, if we draw sine 2x graph, so y equal to sine 2x versus x. Now sine 2x graph will be like this only. Sine 2x graph will be somewhat like this. Now it will go from till 1 and pi by, so here x belongs to, it is told, from pi by 6 to pi by 3. X belongs to pi by 6 to pi by 3. Pi by 6 to pi by 3, where both are included. Now pi by 6 to pi by 3, so it means 2x will go from pi by 3 to 2 pi by 3. Pi by 3 means 60 degree. 2 pi by 3 means 120 degree. So this is at pi by 2, means 2x equal to pi by 2. Here it will be pi by 4, that's why. Pi by 6 is 30, so it will be somewhere here. So sine 2 pi by 6, so sine pi by 3, that is equal to root 3 by 2. So this value is root 3 by 2 at pi by 6. And at sine 2 pi by 3, that will be also sine pi by 3, that is root 3 by 2 only. So it is going pi by 2 pi by 3 is 120 degree. So it is going till pi by 3. So here the values are same. These values are same, which is root 3 by 2. And this is the maximum value which will come at pi by 4. So therefore, sine 2x that will go from, therefore sine 2x that will go from root 3 by 2 to 1 for x belongs to pi by 6 to pi by 3. Pi by 6 to pi by 3. So therefore, 2 plus sine 2x that will go from 2 plus root 3 by 2 till 2 plus 1, that is 3. So therefore, the minimum value of f, that is equal to beta, that is equal to 2 plus root 3 by 2, and the maximum value of the function f in the given values of x, that is equal to alpha, that is 3. So alpha is 3 and beta is, okay, alpha is 3 and beta is 2 plus root 3 by 2. So now therefore alpha square plus beta square, that will be equal to 9 plus, this is 4 plus 3 by 4 plus root 3, no, 2ab, so 2 root 3. So this is not equal to 4 root 3. Similarly, alpha square minus, which is not equal to 9 by 2. And alpha square minus beta square, that will be to 9 minus 4 minus 3 by 4 minus 2 root 3. So that is also not equal to 4 root 3. And then beta square minus 2 root alpha, that will be equal to 2 plus root 3 by 2 whole square. So 4 plus 2 root 3 plus 3 by 4 minus 2 root alpha 2 root 3. So 2 root 3 will cancel. So 4 4 is 16, 16 plus 3, 19 by 4. Yeah. So option B is the correct answer. And similar, so we can tell this beta square plus 2 root alpha, that will be equal to how much? That will be 4 plus 2 root 3 plus 3 by 4 plus 2 root 3. So which is not equal to, so which is 19 by 4 plus 4 root 3, which is not equal to 19 by 4. So it means option C is also not correct. So option B is the correct answer. Then here it is told let f be from r minus 2 comma 6 to r be real valued function which is defined as f of x equals to x square plus 2x plus 1 divided by x square minus 8x plus 12, then the range of f is. So if we take this as y, then we can say that x square plus 2x plus 1, that is equal to x square y minus 8xy plus 12y. So then we can say this will be y minus 1 into x square, then this is 2x. So this is minus 2 plus 8y into x. Then this is plus 12y minus 1, that is equal to 0. So now therefore, if y is not equal to 1, then it should have real and unequal roots. If y not equal to 1, then the value of the discriminant that should be greater than or equal to 0, since it should have its real roots. Should have real roots. Since x belongs to R, we should tell. Since x belongs to R. So it should have real roots. So the value of the discriminant should be greater than or equal to 0. So therefore I can say b square, which is 2 plus 8y whole square, b square minus 4ac, 4ay minus 1 into 12y minus 1, b square minus 4ac, that should be greater than or equal to 0. So here we can say that this will be 2 twos of 2. If we take outside, this will be 4 into 1 plus 4y whole square minus, so that should be greater than or equal to 4 into y minus 1 into 12y minus 1. So 4 and 4 I can cancel out. Then it will come 1 plus 16y square 1 plus 16y square plus for the 8y, that is greater than or equal to, this is 12, this will be 12y minus 1, sorry, 12y minus 1, 12y minus 1. So this will be 12y square minus y minus 12y, so minus 13y plus 1. So 1 and 1 I can cancel it. Then we will say this will be 12, so 4y square, 4y square plus 13 plus 8, that is 21y. 21y, that is greater than or equal to 0. So therefore I can say y into 4y minus plus 21, that should be greater than or equal to 0. And y should not be equal to 1. So therefore from here we can say that y should be either greater than or equal to 0, or y should be less than or equal to y should be less than or equal to minus 21 by 4, and y should not be equal to 1. So therefore y belongs to minus infinity to minus 21 by 4 union 0 to infinity, excluding 1, minus 1. Okay. And then if if y equals to 1, then x will be how much? Then x square plus 2x plus 1, that will be equal to x square minus 8x plus 12. So for x square will cancel, then we will get 10x, that is equal to 11. So x will be equal to 11 by 10, which is also a real number. So if y equal to 1, then also x will come real number only. Therefore y can be equal to 1 also. So this one was case 2, this one was case 1. If y is to 1. So in between the different cases, we should always take union. So therefore here it is coming y belongs to 1. Y belongs to 1. So y can be 1 also. So therefore if you take the union of these two sets, then we will get y belongs to minus infinity to minus 21 by 4 union 0 to infinity. So 0 is also included. So option C is the correct answer. And here it is told to find out the absolute minimum value of this function, the absolute minimum value f of x, that is equal to the absolute value of x square minus x plus 1 and plus the greatest integer of x square minus x plus 1. So we have to find the minimum value of the function f in the interval x belongs to minus 1 to 2. in the interval -1 to 2. So now let's say we take this function as g of x, which is x square minus x plus 1. So then this function f of x can be written as, this will be mod of g of x plus bracket g of x. So therefore now g of x, that is equal to, that we can write x square minus x plus 1 by 4 plus 3 by 4. So this will be equal to x minus half whole square plus 3 by 4. So therefore the minimum value of g, it means g of x will always be greater than or equal to 3 by 4. Therefore the minimum value of g is 3 by 4, which will come at x equal to half, and half is within the given set, and half it belongs to the set -1 to 2. So half we can take. So therefore the absolute minimum value of the function f, that will be at x equal to half only. So that will be equal to bracket of minimum value of g plus the bracket of minimum value of g, means the absolute value of the minimum value of g plus the greatest integer of minimum value of g. So this will be absolute value of 3 by 4 plus bracket of 3 by 4. So this will be 0 only. So this is 3 by 4 plus 0, that will be equal to 3 by 4. So 3 by 4 is the absolute minimum value of this function. So option A is the correct answer. Then here it is told, if the domain of the function f of x, that is equal to bracket x by 1 plus x square, where x, bracket x is the greatest integer less than or equal to x. Here it is told the domain of this function f, that is closed interval 2 to 6 open. So it is from 2 to 6. So it means x can go from 2 to 6. Then its range is. So as we know, the bracket x value, it can be then 2, 3, 4 or 5, since why x is going from 2 to 6. So therefore if I take, if x belongs to suppose 2 to 3, then what will happen? Then the function f of x will be equal to 2 by 1 plus x square. And then if the function f of x will belong to, so if I put, so here as we can see, for 1 plus x square, if we increase the value of x, this 1 plus x square value will also increase. So it is simply an increasing function. So if we put now 1 by 1 plus x square, that will be a decreasing function. It means if we increase the value of x, 1 by x square, 1 by 1 plus x square will decrease. So therefore f of x will go from 2 by 1 plus 3 square, 2 by 1 plus 3 square, that is 2 by 9 plus 1, 10, 2, from 2 by 10 to go 2 to the 4 plus 1 till 2 by 5. Go till 2 by 5. And similarly, this is 0.2, this is 0.4. So it is going from 0.2 to 0.4. And 0.2 is not included since 3 is not included. And similarly, if x belongs to 3 to 4, then the function f of x will be equal to 3 by 1 plus x square. Similarly, then the function f of x, will go from, it will belong to 3 by 1 plus 4 square, 4 4 is 16, 16 plus 1, that is 17. So 3 by 17 to 3 3 is 9, 9 plus 1, 10, till 3 by 10. And if x belongs to 4 to 5, then f of x will be equal to 4 by 1 plus x square. And then the function f of x will belong to, so first we will put 5. So it is 5 square 25 plus 1 26. So 4 by 26, or I can say 2 by 13. 2 to the 4, 13 to the 26. Okay, 2 by 13 to 4 by 4, 4 square is 16 till 4 by 17. And if x belongs to 5 to 6, then the function f of x will be 5 by 1 plus x square. And then the function f of x will go from, will belong to, belong to, first we will put 6 to get the minimum value. So 6 square 36. So 5 by 37 to 5 5s are 25 plus 1 26, still 5 by 26. So we have to find the range. So here f of x, the function f of x, here it is going from 0.2 to 0.4, that is 2 by 10, 0.2 to 0.4. So we have to take the union of all these sets. We have to take the union, and here it is going from 3 by 17, slightly less than, okay, till 0.3, till 0.3. So from 3 by 17 to 0.3, and it is going from 4 by 17. 4 by 17 will be slightly here. 4 by 17. 4 by 17 till 2 by 13. 4 by 13, which will be slightly lesser. And no, 4 by 26 it is. 4 by 17, this is 4 by 26 or 2 by 13. And here it is 4 by 26. This is 4 by 26. So 5 by 26 will be slightly higher than this. Here it is 5 by 26. So it is going from 5 by 26 to 5 by 37, which will be slightly lesser, 5 by 37. So here actually what is happening, that if we take the union of these three sets, these four sets, 0.2 to 0.4. So then it is going from, yeah. So here if we take the union of all these four sets, then it will go from 5 by 37 to 0.4, means 4 by 10, means 2 by 5. So therefore f of x will belong to 5 by 37, where it is not included. This value is not included, but 2 by 5 is included. So 5 by 37 to 2 by 5. By 37 to 2 by 5. So option B is the correct answer. And here you have to find the range of this function. So here if the function f of x is root over 3 minus x plus root over 2 plus x. So now 3 minus x, that should be greater than or equal to 0. So it means x should be less than or equal to 3. And 2 plus x, that should be also greater than or equal to 0. So it means x should be greater than or equal to minus 2. So therefore x should be greater than or equal to minus 2 and to 3 till 3. So this is the domain. This is the domain of the function f. Domain of the function f, that is minus 2 to 3. This is the domain. Now the range you have to find out. So now therefore f dash x, we can find f dash x, that is equal to d by dx of this, which is 1 by 2 root over 3 minus x into minus 1, plus this is 1 by 2 root over 2 plus x into 1. So this will be equal to 1 by 2 root over 2 plus x minus 1 by 2 root over 3 minus x. So this will be 4 into, no, this will be, the LCM will be 2 into root over 2 plus x into 3 minus x. And here it will be root over 3 minus x minus this will be root over 2 plus x. So if this is equal to 0, then we will have the maximum or minimum value. Okay, so if f dash x, that is equal to 0, then we have the extremum, then we have the maximum or minimum value of f can be obtained. Okay. Now therefore 2 plus root over 2 plus x, that should be equal to root over 3 minus x. If the f dash x, that should be equal to 0, so then we will get 2 plus x, that should be equal to 3 minus x. So then 2x, that is equal to 1, 2x, that is equal to 3 minus 2, 1, so x will be equal to half. So therefore now f of half, if we can find out, f of half, that will be root over 3 minus half plus root over 2 plus half. So this will be root over 2 3 is 6, 6 minus 1, that is 5 by 2, root over 5 by 2, plus this is root over 2 to the 4 plus 1, 5 by 2. So this is 2 into root 5 by root 2, so that is root over 10, root 2 root over 10. And then similarly f of minus 2, that will be root over 3 minus of minus 2 plus root over 2 minus 2. So this will be 0, this will be root 5. And similarly f of 3, we have to find the values of f at the endpoints of x. So this will be root over 3 minus 3 plus root over 2 plus 3. Minus 2, okay. And at 3, this will be also equal to root 5. So therefore the minimum value of the function f, that is equal to root 5, and maximum value of the function f, that is equal to root 10. Therefore the function f of x, that will belong to root 5 to root 10. So it means this is the range of the function f, and so option D is the correct answer.